Hi everyone, this is Sash from eClass Education. In this video we'll be continuing with the solutions to Paper 1, November 2018. Question 2. Please see our other videos for the rest of the solutions. In question 2.1, we're given the quadratic sequence 2, 3, 10, 23, and so on. And we need to write down the next term of the sequence. So we're looking for this value over here. We know that this is a quadratic sequence, which will have a second constant difference. Let's write down the sequence over here. 2, 3, 10, 23, and so on. Now we'll write down the first difference. So from 2 to 3, we're adding 1. From 3 to 10, we're adding 7. And from 10 to 23, we're adding 13. Now, if we knew this value over here, we could find the next term of the sequence. We'll need to find the second difference to find this value. From 1 to 7, we're adding 6, and from 7 to 13, we're adding 6. So 6 is our second constant difference. We'll add 6 again to get the next term in the first differences. So the next first difference will be 13 plus 6, which will be 19. And now we're ready to find the next term of the sequence. 23 plus 19 will give us 42. So the next term of the sequence is 42. For question 2.1.2, we'll draw a line here so we can separate our answers. We need to determine the nth term of the sequence. And the nth term of a quadratic sequence is given by term n is equal to an squared plus bn plus c. And once we have the values of a, b, and c, we'll be able to find any term in the sequence. Now, for a quadratic sequence, what we need to remember is that the second difference is equal to twice the value of a. So the second difference is equal to 2a. And what is the second difference? The second difference is 6. So 6 is equal to 2a, and a will be equal to, we divide both sides by 2, a is equal to 3. So we can write term n is equal to 3n squared plus bn plus c. And now we need to find the values of b and c. Now we'll write equations for term 1 and term 2, and then solve these equations simultaneously to find b and c. We'll use term n is equal to 3n squared plus bn plus c to write the equations. Term 1 is equal to, and the value of term 1 is 2. Term 1 is equal to 2, which is equal to 3n squared, 3 and n squared is 1 squared, plus b times n, which is 1, plus c. So 2 is equal to 3 plus b plus c. We'll write b plus c on the left, and that's equal to 2 minus 3, which is minus 1. And we'll call this equation 1. Term 2 is equal to, and the value of term 2 is 3, which is equal to 3n squared, 3 times 2 squared, since n is now 2, plus bn, which is 2, plus c. 3 is equal to 3 times 2 squared, which is 4, is equal to 12, plus 2b plus c. Writing 2b plus c on the left is equal to 3 minus 12, which is minus 9. And we'll call this equation 2. Equation 2 minus equation 1 will eliminate c. Equation 2 minus equation 1. We have 2b minus b will leave us with b. C minus c is 0, and that's equal to minus 9 minus minus 1 is minus 8. And we'll substitute b equals minus 8 into equation 1. That will give us minus 8 plus c is equal to minus 1. So c is equal to minus 1 plus 8, which is 7. We'll draw a line here so we can continue working on the right. Now we have values for b, which is minus 8, and c, which is 7. So we can write term n is equal to 3n squared, and the value of b is minus 8, minus 8n, and c is 7. So we have the nth term of the sequence. In question 2.1.3, we need to calculate the 20th term of the sequence. So term 20 is equal to 3 times n squared, which is 20 squared, minus 8n, which is 20, plus 7. And this is equal to 3. 20 squared is 400, minus 8 times 20 is 160, plus 7, that's equal to 1200, minus 160, plus 7, and that's equal to 1047. So the 20th term is 1047. In question 2.2, we're given the arithmetic sequence 35, 28, 21, and so on. And we need to calculate which term of the sequence will have a value of minus 140. We'll write the sequence down here: 35, 28, 21, and so on. And somewhere in the sequence lies the value minus 140. And we want to know in which position the term is in. So minus 140 will be term n, and we want to know the value of n. We know the equation for the nth term of an arithmetic sequence, and that is term n is equal to a plus n minus 1 d. Term n is the value of the term in the nth position, which in this example is minus 140. A is the first term, which is 35. N we don't know yet, and D is the constant difference of this arithmetic sequence. So let's find D first. D is the constant difference between the terms. So from 35 to 28, we minus 7. From 28 to 21, we minus 7. So D is equal to minus 7. Now let's substitute into the equation and find the value of n. Term n is minus 140, which is equal to 35 plus n minus 1, and D is minus 7. That's equal to 35. Now we'll distribute minus 7 over the terms in the bracket. So minus 7 times n and minus 7 times minus 1. Minus 7 times n is minus 7n, and minus 7 times minus 1 is plus 7. Now we want to move minus 7n onto the left hand side, so we add 7 to both sides. That will give us 7n. And we want to move minus 140 to the right hand side, so we add 140 to both sides. And that gives us 35 plus 7 plus 140. So 7n is equal to 182. So n will be equal to, and we divide both sides of the equation by 7, n is equal to 26. This means that minus 140 lies in the 26th position in the sequence. Question 2.3. For which value of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? Now this is rather a long question, so pause the video and read through the question first before we begin with the solution. Now, what are we looking for in this question? We need to find the value of n when the sum of the first n terms of the arithmetic sequence in question 2.2, so this is question 2.2, and we're looking at the arithmetic sequence. So we want to know the sum of the first n terms of this arithmetic sequence. So we're looking for sum n of the arithmetic sequence. And this sum must be equal to the nth term of the quadratic sequence in question 2.1. So this is 2.1. And this is the quadratic sequence. So we're looking for the nth term, meaning term n. And we worked that out already to be 3n squared minus 8n plus 7. So in this question, we're looking for the value of n when sum n of the arithmetic sequence is equal to term n of the quadratic sequence. So let's begin. Now we'll write down the formula for sum n of an arithmetic sequence, which is equal to n over 2 times 2a plus n minus 1 d. And that's equal to n over 2, we don't know n, times 2a, and a is 35, plus n minus 1, and d we worked out previously to be minus 7. And that's equal to n over 2 times 70 minus 7n plus 7. That's equal to n over 2 times 77 minus 7n. And the formula for the nth term of this quadratic sequence is term n is equal to 3n squared minus 8n plus 7. Now we'll move the page up to give us some more space to work. Remember, we're looking for the value of n when sum n is equal to term n. So n over 2 times 77 minus 7n is equal to 3n squared minus 8n plus 7. So n over 2 times 77 minus 7n is equal to 3n squared minus 8n plus 7. We can multiply both sides by 2. That will give us n times 77 minus 7n is equal to 6n squared minus 16n plus 14. On the left-hand side, we'll have 77 times n minus 7n squared, and we can bring the terms from the right-hand side to the left-hand side, and that will give us minus 6n squared plus 16n minus 14 is equal to 0. Adding the like terms, we have 77n plus 16n, which will give us 93n, minus 7n squared minus 6n squared is minus 13n squared minus 14. Is equal to 0. Now we can multiply through by minus 1. That will give us 13n squared minus 93n plus 14 is equal to 0. And we're ready to factorize. It's equal to 0. 13n squared will be 13n times n, and the factors of 14 will be 2 and 7. 13 times 7 will give us 91, plus 2n will give us 93n. And the signs will both be minus. So we have 13n minus 2 is equal to 0. So n is equal to 2 over 13, or n minus 7 is equal to 0, and n is equal to 7. Now, since n is the position of the term in the sequence, n is a whole number and cannot be a fraction. So n is equal to 2 over 13 is not a solution. So the value of n we're looking for is n equals 7.